Good morning to everyone. I'm Dr. Sumi MS. The name of the course is Electric Circuit Analysis, and today's lecture topic is Resistors in Series Circuits. On completion, the students will be able to differentiate between AC and DC circuits and obtain the expression for resistance in a series circuit. DC circuits. A DC circuit, that is a direct current circuit, is an electrical circuit that consists of any combination of constant voltage sources, constant current sources, and resistors. In this case, the circuit voltages and currents are constant, that is independent of time. Also, DC circuit has no memory. That is, a particular circuit voltage or current does not depend on the past value of any circuit voltage or current. This implies that the system of equations that represent a DC circuit do not involve any integrals or derivatives. Fundamentals of AC. An alternating current is an electrical current where the magnitude of the current varies in a cyclical form as opposed to direct current where the polarity of the direct current always stays constant. The usual waveform in an AC circuit is generally that of a sine waveform, as this results in the most efficient transmission of energy. However, in certain applications, different waveforms are used, such as triangular, square waves, etc. Difference between AC and DC. Current that flows continuously in one direction is called direct current DC. Alternating current is the current that flows in one direction for a brief time, then reverses and flows in the opposite direction for similar time. The source for alternating current is called an AC generator or alternator. Cycle. One complete set of positive and negative values of an alternating quantity is called one cycle. Resistors in series circuit. The following diagram shows three resistors R1, R2 and R3 connected end to end, that is in series, with a battery source of V volts. Since the circuit is closed, a current I will flow and the potential difference across each resistor may be determined from the voltmeter readings V1, V2 and V3. In a series circuit, the current I is the same in all parts of the circuit and hence the same reading is found on each of the two ammeters that are connected. From the diagram, the sum of the voltages V1, V2 and V3 is equal to the total applied voltage V. That is, V is equal to V1 plus V2 plus V3. From Ohm's law, we shall write V1 is equal to I into R1, V2 is equal to I into R2 and V3 is equal to I into R3. And as a whole, V can be written as I into R, where R is the total circuit resistance and V is equal to V1 plus V2 plus V3. Then we shall write V equal to IR, that is IR is equal to IR1 plus IR2 plus IR3. Dividing throughout by I, we shall get R is equal to R1 plus R2 plus R3. Thus, for a series circuit, the total resistance is obtained by adding together the values of the separate resistances. Problem 1. For the circuit given below, determine the battery voltage V, the total resistance of the circuit, and the values of resistance of resistors R1, R2 and R3, given that the voltage across R1, R2 and R3 are 5 volt, 2 volt and 6 volts respectively. Battery voltage V is equal to V1 plus V2 plus V3, which is equal to 5 plus 2 plus 6 equal to 13 volts. The total circuit resistance R is equal to V by I, that is 13 divided by 4, which is 3.25 ohms. Resistance R1 is equal to V1 by I, R2 is equal to V2 by I and R3 is equal to V3 by I. That is, R1 is equal to 5 by 4, which is 1.25 ohms. R2 is equal to 2 by 4, which is 0.5 ohms, and R3 is equal to 6 by 4, which is equal to 1.5 ohms. Quiz questions on resistors in series circuits. What are DC circuits? Define an alternating current. Thank you.